mechanism. So this is what I was saying before, is that one is more of a two-step reaction. So there's one rate determining step. That's forming here. And in a second step, a Cl1 that does an SN1 mechanism. This is how it works, is that the Br leaves. You have this nice Br ion leaving. This carbon used to have 4 bonds. Now it only has 3 bonds. And so it has lost, this bonding pair of electrons went with Br. And so this carbon has lost electrons, which means if it's losing electrons, it should be positive. Losing negative charge would make it more positive. And this is where this carbocation comes in. So now we have this tertiary carbocation. And then this, CO ion that was happening to float around in the solution, it comes in with its own pair of extra electrons, forms a 4th bond, and you get this new molecule. The reason that's it's saying it's always tertiary is because tertiary carbocations, meaning that the carbon has 1, 2, 3 things around it, is much more stable than a primary carbocation, one that only had 1 thing around it. Is kind of showing how this happens. This is once again the bonding pair of electrons goes with the L. This is an electronegative atom, meaning that it's stealing a lot of it away. So there's already a dipole moment away there. That's what that delta negative means. And now you have your nucleophile come in and then add to that carbon, forming that 4th bond. Donating electrons, negative and positive, should cancel out to 0. And that's why there's no charge there. Right, so continuing, so SN2 is always for primary. So that means that it's a conservative mechanism. It's 1 step. You can see this is a carbon that is primary, meaning it's only attached to 1 other carbon. And this OH will come in, kick off the Br in 1 quick step. This is formed, the Br leaves. This is an example of actually a methyl chloride, which is actually even better than primary, where the ranking goes methyl, then primary, then secondary, then tertiary. So this is a methyl chloride, meaning that the carbon is only attached to just hydrogen, it's nothing else. You can see this OH comes in 1 quick step, takes off the chlorine. This is formed, chloride leaves. E1 and E2, this is the same kind of idea, but now instead of adding, you are eliminating things. And this is an E2, let's see here. And this is also favorited based off these substrates. So more specifically, what I said before is right, where it's E2 is the 1 step and E1 is the 2 step, but it's talking more on the base. So instead of the arrangement of the actual atoms, primary, secondary, tertiary, it's really focusing on what the actual base is. So like what it's reacting with. OH is an extremely strong base because when OH gets that H, it becomes water. That's a very stable molecule. And so for these reactions are favored by strong bases. These strong bases are going to be this OH, but also you have this methoxy, this ethoxy, and tert-butyl. These are very strong bases. And also the way that E2 happens is it's called beta elimination. So this carbon has this bromine, and this bromine is actually facing the opposite way as this H. You can see this is facing up and down. And so when they're facing in these opposite directions, this OH takes the H, and in 1 quick step, this bonding pair of electrons becomes a double bond. This bonding pair of electrons goes with the Br. So now you get the double bond, H2O, and Br minus, 1 quick step. And now we're talking about E1 reactions are favored by weak bases. So weak bases, water and alcohols. Water can accept the proton and becomes H3O, but it's not as quite stable as water, and also alcohols. And this is, let's see, so in 1 quick step, you get this Br kicking off. It's going to form this tertiary carbocation. So there is a little bit of play in here with that tertiary effect. You can see, remember, like I said before, with SN1 mechanisms, the primary or tertiary carbocation is much more stable than the primary. Here you have this tertiary carbocation, so it wants to form this. And then this H is now attacked by this alcohol. This bonding pair of electrons goes there. So you can see this E1 is a 2-step reaction. This E2 is a 1-step reaction. And so E1 unimolecular. Let's see what it's doing here. And I think what it means by that is E1 unimolecular, meaning we'll go to the E2. So the E2 is bimolecular, meaning there are two molecules required for this one step to happen. You can see this unimolecular happen. This BR doesn't need anything really. It can just form a tertiary carbocation. So it's unimolecular. Going back here, this E1 reaction, the BR just leaves. Nothing happens. The BR just is like, wow, I don't want that BR. Or I don't want to be on that molecule anymore. So it's unimolecular. This is bimolecular. There's two molecules at reaction mechanism. So E1 unimolecular, E2 bimolecular.